Welcome back to Tech Search News, where we bring you the latest in the world of science and technology. The challenge for many countries today is obtaining enough energy to meet rising demand. Although fossil fuels and nuclear power plants are viable options, they are fraught with complications. However, thorium reactors, a new type of energy production, promise to save the day. What kind of thorium reactors are there? How do they work? And who is involved in their development? Join us as we delve into new thorium reactors that may have the potential to change everything. Without power, there is no economy. As a result, the world's leading economies are constantly clamoring to boost their energy production. When it comes to energy production, there is frequently an unfavorable byproduct: pollution. In 2019, for example, nearly 2/3 of global electricity came from fossil fuels, while nuclear energy accounted for 10.4%. Coal, crude oil, and natural gas are all classified as fossil fuels because they were formed from buried fossilized remains of plants and animals that lived millions of years ago. Because of their origins in high carbon content fossil fuels, using fossil fuel to produce energy brings with it a slew of issues that many countries are attempting to avoid. For example, unearthing, processing, and transporting underground oil, gas, and coal deposits wreak havoc on our landscapes and ecosystems. The fossil fuel industry leases vast swaths of land for infrastructure such as pipelines, wells, access roads, and processing, storage, and disposal facilities. Coal, oil, and gas development endangers our waterways and groundwater. Coal mining operations discharge acidic runoff into streams, rivers, and lakes, as well as large amounts of unwanted rock and soil. Spills and leaks caused by oil extraction or transportation can pollute drinking water sources and endanger entire freshwater or ocean ecosystems. That's before we even get into emissions. Furthermore, long before they are burned, fossil fuels release harmful air pollutants. Indeed, approximately 12.6 million Americans are exposed to toxic air pollution on a daily basis from active oil and gas wells, as well as transport and processing facilities. These include benzene, which has been connected to childhood leukemia and blood disorders, and formaldehyde, a carcinogen. We contribute to the current global warming crisis by burning oil, coal, and gas. When fossil fuels are burned, they emit a large amount of CO2. Carbon dioxide emissions trap heat in the atmosphere, causing climate change. The burning of fossil fuels, particularly in the power and transportation sectors, accounts for roughly 3/4 of our carbon emissions in the United States. When fossil fuels are burned, they emit more than just carbon dioxide. Coal-fired power plants are responsible for 42% of dangerous mercury emissions in the United States, as well as 2/3 of sulfur dioxide emissions in the United States, which contribute to acid rain and the overwhelming majority of soot or particulate matter in our air. Nuclear energy is not without its own baggage. The Fukushima nuclear disaster is proof of this. This disaster occurred as a result of a powerful earthquake and tsunami in March 2011. Although the chain fissile reactions were automatically shut down in response to the earthquake, the tsunami damaged the generators that cooled the power plants. Without cooling, all of the energy released by these reactions can literally melt the components of the reactor's core. They did in this case. Following that, radioactive material was released, as well as several chemical explosions caused by the enormous heat released by the nuclear reactions. Furthermore, the waste produced by nuclear reactors is radioactive for tens to hundreds of thousands of years. There are currently no long-term storage options for radioactive waste, and the majority distort in temporary above-ground facilities. These facilities are nearing the end of their storage capacity. The nuclear industry is shifting to more expensive and potentially less safe storage methods. Aside from the considerable risk of cancer associated with nuclear disaster fallout, studies indicate a higher risk for those who live near nuclear power plants, particularly for childhood cancers such as leukemia. Workers in the nuclear industry are also exposed to higher than normal levels of radiation, putting them at a higher risk of cancer death. There is also the issue of nuclear reactors needing to be located near a water source for cooling, and there aren't enough places in the world that are safe from potential disasters such as droughts, flooding, hurricanes, earthquakes, and other natural disasters that could cause a nuclear accident. Climate models predict an increase in extreme weather events, which only adds to the risk. However, a new technology promises to forever alter the face of energy production. It's called the thorium reactor. But what exactly is thorium? Thorium, named after Thor, the Norse god of thunder, was discovered in 1828 by Swedish chemist Jöns Jacob Berzelius. It is a slightly radioactive metal found in trace amounts in rocks and soils all over the world. But it is especially abundant in India and the state of Idaho. Thorium has only one major isotope, thorium-232, while the others exist in trace amounts. This isotope decays into the lead isotope lead-208. But what makes thorium appealing is that it can easily absorb passing neutrons, converting it into thorium-233. In a matter of minutes, this new isotope emits an electron and an antineutrino to form protonium-233, an isotope of protonium. With a half-life of 27 days, this then converts into uranium-233, a uranium isotope. Water is not required to cool thorium reactors. Molten salt nuclear reactors, which use liquid thorium instead of uranium, are safer than traditional reactors. This is because when exposed to air, the molten salt quickly cools and solidifies, insulating the thorium so that any potential leak will release far less radiation into the external environment than leaks from traditional reactors. Molten salt reactors operate by dissolving thorium in liquid fluoride salt and sending it into the reactor chamber at temperature above 1112 Fahrenheit or 600 degrees Celsius. When thorium atoms are bombarded with high-energy neutrons, they get converted into uranium-233, an isotope of uranium that can then split, releasing energy and even more neutrons via nuclear fission. This initiates a chain reaction that releases heat into the thorium salt mixture, which is then passed through a second chamber where excess energy is extracted and converted into electricity. The waste products of uranium-235 nuclear reactions are highly radioactive for up to 10,000 years and contain plutonium-239, a key ingredient in nuclear weapons. Traditional nuclear waste must be stored in lead containers, isolated in secured locations, and subjected to stringent controls to avoid falling into the wrong hands. In contrast, the main byproducts of a thorium nuclear reaction are uranium-233, which can be reused in other reactions, and a number of other byproducts with half-lives of less than 500 years on average. Because of the benefits of thorium over other nuclear fuels, Chinese government scientists have revealed plans for a first-of-its-kind thorium nuclear reactor. The prototype reactor, which will be finished soon, will lay the foundation for the construction of the first commercial reactor. The first commercial reactor will be built in the desert city of Wuwei, and the Chinese government intends to build more throughout western China's thinly populated deserts and plains. The new reactor is part of the Chinese President Xi Jinping's efforts to make China carbon neutral by 2060. China currently contributes 27% of total global carbon emissions, the most of any individual country and more than the whole developed world combined. China intends to construct its first commercial thorium reactor after testing the 2-megawatt prototype. Researchers claim that despite being only 10 feet or 3 meters tall and 8 feet or 2.5 meters wide, it will be capable of producing 100 megawatts of electricity, enough to power 100,000 people. To generate usable electricity, it must be combined with other equipment such as steam turbines. Aside from China, another company called Thorium is developing a thorium reactor. Thorium intends to construct a pilot plant in Wyoming in the United States. Bill Gates and Warren Buffett, both billionaires, have invested in the company. Companies in India are also building thorium reactors due to the abundance of thorium in the country. Advanced heavy water reactors are one type of thorium reactor. These are reactors in which neutrons are slowed or moderated by heavy water, which has the same chemical formula as ordinary light water. Deuterium, which is hydrogen with an extra neutron, replaces the hydrogen atoms. Light water circulates naturally in a pool driven by gravity to provide cooling. So, what do you think? Please share your thoughts on thorium reactors in the comments section below. That is all we have for today, and if you enjoyed the video, why don't you give us a like and subscribe to TechSurge News to hear the latest and greatest in the world of science and technology. Don't forget to hit the bell button below to get notifications on when we post next. Thank you for staying till the end of the video and hope you enjoyed. TechSurge News signing out.